All right, so on the back of this sheet, I know some of you were looking at these examples ahead of time. I have at the top, it says the most general antiderivative of f on the interval I is, and it's written as capital F of x plus c. So it's including that plus constant, and then it does include after where c is a constant. So you need to remember anytime you're taking an antiderivative to have the plus c. And if it asks for the most general antiderivative or just an antiderivative, that's what the most general means, is you're including that plus c at the end. And then I have a few examples, and these all have kind of a special case to them, or at least the first two do, with working through these. These are less straightforward than the ones that you had on the front. So example, I didn't put a 1 there, should be example 1. But it says find all functions g such that g prime of x is equal to 4 sine of x plus 2x to the 5th minus the square root of x all over x.
Do you have to like work backwards and chain rule or something like that?
Okay, so I will say this right now in 4.9. No. We are not finding antiderivatives. That would be the reverse of the product, quotient, or chain rule. We are not. And that means when you have a function like this, you should be able to rewrite it so that you're only doing the reverse of trig functions or power functions or natural log or logarithmic functions. So you're not doing the reverse of product, quotient, or chain rules right now. We will learn the reverse of the chain rule, but not until the end of chapter 5. So to do this, I would rewrite this quotient using algebra. How could I rewrite that? Okay. Yes. So, or I could even do this too. So you could take this and multiply the whole quantity by x to the negative first, or multiply by 1 over x, or you could write it this way as both of the terms in the numerator over x. I mean, that would be the same as multiplying them both by 1 over x, distributing the 1 over x, so plus 2x to the 5th over x minus the square root of x over x. So you can split the fraction, split the numerator into 2 fractions. And then why that's helpful, 2x to the 5th over x, how can you simplify that? Yeah, so you can subtract those exponents. So g prime of x is 4 sine of x plus 2x to the 4th. Now this x, or square root of x, would be x to the 1/2. So then it would be minus x to the negative 1/2. So it's kind of like when we first started with derivatives, you wanted to simplify because you didn't know the product or quotient rules yet. Same thing applies here. You're simplifying because we don't have a reverse of the product or quotient rules right now. So simplify first if you can. Then you're taking the antiderivative of every term. So when I take the antiderivative, because it said find all functions g, so antiderivative of g prime would be g of x. And coefficient, that rule still applies if there's a coefficient in front. The coefficient stays, and it's just multiplied by the antiderivative of that term. So if I have 4 sine of x, it's going to be 4 times the antiderivative of sine, which the antiderivative of sine of x is what? Negative cosine, yes. So this would become negative 4 cosine of x. And then I would have the antiderivative of 2x to the 4th. Now, on the front, I don't have it written on mine because I know Jake showed his, but it was this rule right here, the reverse or the antiderivative for power rule And if we wanted to include the a, like Dalton talked about, so if you have a coefficient, it's adding 1 to your exponent and then dividing the coefficient in front by your new exponent, as long as n doesn't equal -1, because if your power is -1, you really have 1 over x, and that's something different. So if we have 2x to the 4th, what would that antiderivative be? Yes, so plus 2/5 x to the 5th. So add 1 to the exponent and then divide the coefficient by the new exponent. And then we have minus. What about the antiderivative for x to the -1/2?
Would it be -2x to the half?
So, okay, so if we add 1 to the exponent, we now have a positive 1/2. And in front, it'd be 1 over 1/2, which would be 2. So it'd be minus 2x to the 1/2. So when your exponent, your new exponent is a fraction, what goes in front is the reciprocal of it, because it's 1 over that. And then if we want all functions g, we have to include a plus c at the end. There could be a constant, so that when we take the derivative, that would be 0, but there could be a constant there. So this would represent all functions g. C could be any number. So there are infinitely many functions listed there in that statement. Okay, questions on that?
Oh, I forgot.
For the next one, for example, 2, this one, there's something special in the way you would write the answer. Yeah, so I would rewrite this. It says find the most general antiderivative for this function. So I would rewrite this as 10x to the -9th before you find the antiderivative. And then to represent the antiderivative of little f of x, you would use capital F of x.
No.
Antiderivative would be what? So yeah, adding 1 to the exponent is at x to the -8th. So then it would be 10 over -8, which then this could be simplified. So -5/4 x to the -8. And then you would have to include a plus c for the constant. Now, this one is written differently. This is not, if you're working on the practice, you're checking answers in the back, you would not see the answer left like this, because in this case, the x, and this matters for antiderivatives, the x is in the denominator, meaning x cannot be 0. So how they have this written when you're checking answers in the back, and this is just so you understand that if you are checking, they have it written as a piecewise function. So for x values less than 0 and greater than 0, since x can't equal 0. So they would write it as -5/4 x to the -8 plus a constant, but they would say c sub 1, and that would be if x is less than 0. And then you'd have the same function, but it could be a different constant, so plus c sub 2 if x is greater than 0. So if you see this, that is why x would not be, or 0 would not be included in the domain. You should, well, I'm showing you this because I know this is how they have it written in the back if you're checking. I have not seen in the past with AP questions an answer that would even have to be written this way. I haven't seen that with questions. But if you're checking your answer in the back, that's why this is written this way. I mean, you could include here 2x can't be 0. That's really what this is saying. I'm just showing you the notation that they're using in the back.
Okay.
All right, and then 3 I just included because sometimes the radical functions can be tricky. So go ahead, find the antiderivative for example 3.